Today we are going to learn Faraday's second law. In previous video we heard completed Faraday's first law. If you want to know Faraday's first law, then go to the earlier video. So let's begin. Before Faraday's second law, you have to know Faraday's first law. In Faraday's first law, Faraday states that whenever in a coil if there is any change in magnetic flux, then an induced EMF is produced, right? Or if any change in magnetic flux, an EMF will induced, right? So in Faraday's second law, we are going to know the magnitude of induced EMF, right? Faraday's first law. I am repeating again. Faraday's first law states that if there is any changes in magnetic flux, then an EMF will induced, right? In second law, we have to calculate that magnitude of the EMF, right? There is a galvanometer, north-south pole. In previous video, we heard completed the first law, so you may go to see that video or watch that video. So in second law, we should write the definition. The magnitude of EMF induced in a circuit is directly proportional to the rate of change of magnetic flux. Linked with the circuit. Right? So basically, it states that if there is a magnet, we can call bar magnet, right? It is north pole and that is south pole. There is a coil. If we take it close to the coil, then an EMF is induced, right? That means in Faraday's first law, we had already learned that how the EMF is produced or induced. In this law, we have to calculate the magnitude of the EMF, right? So it states that the EMF is directly proportional to the magnetic flux. So mathematically, it represents E is directly proportional to d phi by dt, right, where E is represent EMF, right? We can write E equal to minus N d phi by dt, where N represent the number of turn in the coil, right? And we take minus sign because of that the direction of induced EMF is such that it opposes the change in magnetic field, right? I mean to say it opposes, right, the change in magnetic flux. That's why we take minus sign. I hope you will understand. So this is very simple. Let me repeat again. The magnitude of EMF induced in a circuit is directly proportional to the rate of change of magnetic flux linked with the circuit. That means we have to calculate the magnitude of EMF which induced, right, with the circuit by the rate of change of magnetic flux, right? This is very simple. I hope you will understand. Thanks for watching. Tata. Take care all of you.